YouTube channel later.
Awesome.
You're recording. Okay, cool. So that's so you've all been, fair disclosure, it's recording. So welcome. Thanks for joining us, guys. This is ChiNamo, the Chicago Dynamo user group. Myself and Frank here. We've been running this show for, God, Frank, what has it been, like 3 years now? I can't even believe how long it's been.
It's our third year, yeah.
Yeah, it's been a long time. So we mostly a face-to-face group until COVID, and like everybody, we've had to pivot to this online. But the nice thing about online is we can grab speakers like you guys from all over the place. So we don't have to rely just on local presenters anymore. So who knows? Maybe we'll mix it up a little bit when we get back to face-to-face. But this week, everyone, thanks for joining. We've got Sean and tell me again, Mod.
Yes, it's Majd, as
Majd.
it's written, yes.
Okay, sorry. And
No
they've created a package called Sparrow for Dynamo, and it's mostly MEP focused. Is that right, Sean? Or
I'd say the majority of it's MEP focused.
Okay.
There's a little bit something for everyone in there. Some stuff that's totally not MEP, but yeah, overall MEP.
All right. Well, I'll let you, dive into that when we get started here. I just wanted to briefly some of you heard me mention Yahtzee dice and like, what was that about? Well, Sean and I met at a Built, I think it was, or RTC or something a few years ago, and he was standing in a booth and just said to me, hey, called me over and started asking me if how hard it would be to create dice in Revit, and I was like, well, it shouldn't be that hard, And so we were talking about it, and then we emailed later, and so I ended up making this die family for him that had rotation parameters in it, and then he wrote some code to actually roll the dice and created a little. I forgot exactly what you called it. It was a take on Yahtzee in Revit.
I think it was ROTC.
ROTC,
we
yeah.
called it ROTC.
Yeah, and then I was called out by somebody in the forum who said that I did my pips wrong on the die because they're always supposed to add up to 7. So I had to rearrange the family a little bit to make sure that my numbers were on the right faces. But so that was an experience.
Vegas doesn't know that, sure.
Yeah, I didn't know. I mean, I've never created a die before. How would I know that? So, and then for those of you that don't know, die is one and dice is plural. Okay, so that's why I'm saying die. It's one die or more than one dice. So anyway, with that, take it away, Sean and Maj. Go ahead. Wow us with your package. We're very excited to have you here. Thanks for coming.
Yeah, thanks for having us, guys. Yeah, so I'm Sean. I'm a mechanical engineer, I guess, along with Mej, and I'll let him talk a little bit about himself. But yeah, we created this package for a couple reasons. We'll get into that here in a second. Mej, if you want to give a brief little summary of yourself.
Yeah, also a mechanical engineer, and lately I've been venturing into the world of automation and the Revit API. So that led to the creation of build tools, and I've met Sean on the internet, which was something great, and we've built kind of like a friendship, and that led to the creation of Sparrow.
I feel like I know Mej really well. We've been working on MEP stuff together, solving problems for almost 3 years now, maybe about 3 years. And we've never met in person, but my wife's from Turkey. He's in Lebanon, so I shall make it over there soon. I've been trying to get him to get over here. So about Sparrow, we just want to give a huge shout out to the community. We did not build every node, write every piece of code inside the package ourselves. We got inspired by different packages. We straight copied stuff from different packages. So really, it's it's the community, it's the people before them, it's the conferences and other talks that I've heard from people that inspired me. So shout out to these packages, shout out to the community, and more particularly, shout out to these people. These are all people, and what's really cool to me about it is these are people from all around the world. Like we have Mej over in the Middle East. We almost hit every continent in this, 6 people. But these are all people that have taken time out of their day to help me with problems.
We had Mustafa on last time.
Yeah, so Data Shape's amazing, still on there. Ryan's actually the brains behind TestFit, which I'm sure a lot of you guys know about. Takeo's MEP over package. Jacob is with Autodesk in the team. Juan's over in Singapore. He has a package out actually too. And then he's with Topologic. So yeah, all people, great community. So that's the thing. We really built Sparrow. So AU happened. and this last year, and we took on a really ambitious class that had a lot, and I kind of dropped the ball, and I realized, like, right, we have all this Dynamo code, like I did, and I didn't have a package yet or a way to like house it all. So just to keep it all organized, to make everything work, is really important to organize it. So that's really our first goal of making it. Mej, you want to talk about the second goal and kind of what we've done and why with the testing?
Yeah, so always the end goal behind anything is to disrupt the entire industry and try to make a change. So, and you can't do that alone. So we need the entire community to participate in that. Now, of course, Dynamo has its own built-in nodes, but there are some functionalities that need to be introduced and that we're working on to try and achieve that goal. So we wanted to include these functionalities to help us in our R&D to achieve that goal. So we created many of the nodes, which we'll be talking about later on, to include many of the stuff that are missing, to have the entire community help us with our testing and R&D. Yeah.
Yeah, so I found on our journey is like, right, you can never get all the edge cases. So having the community try to test these things out and find where they fail. And, you know, Dynamo being open source and free. So again, thanks to that community. And yeah, we really just want to introduce this idea of computational design for MEP. You know, there's a lot more talk, I think, in the architectural world for it. And I think not enough talk in the MEP world. If anything, I think MEP problems are better for computational design, right? Everything that an MEP engineer does is measurable. It's not, does this look good? Everything's very concrete, measurable. So I think it's better. Yeah, so today we're just gonna, we were kind of preparing some stuff, but so I have some stuff kind of already wired up. I'd love to hear from the community. Please ask questions. We're already 15 minutes through this thing. So, you know, I'd rather hear from you guys, get you engaged. So if we spark an idea, please say something. But we're gonna go through some workflows, and we're really gonna try to talk about the why of some of it, the how, and then of course the workflows are the what we can do with it. So yeah, and then after, if you're still interested, we've started a channel. We haven't been posting because we've both been really busy, but our goal is to keep this thing rolling. I think the description said 250 nodes. We're nowhere near that. We have 250 nodes that we want to build, but it just takes time. So it's an ongoing process. So if you want to join the journey, please follow and subscribe to the Sorry, I hate it. I always think it's cheesy when people do that, but yeah. So let me get, yeah, right. Let me get into Revit. So I'm not an architect. I threw this together. I didn't want to use a production model. So I've been in a couple of production models, but I didn't want to use those. So I want to keep it simple. So we have a link model in here. Real simple. The template, by the way, is just the out of the box template. So of course we're going to go to Dynamo.
We're still seeing your PowerPoint.
I probably need to share a different screen then. I guess while I do this, if you want to send the feeler out of, you know, architects versus engineers, I'm just a little curious. Stop sharing.
I don't know if Teams has a polling feature or not. So I guess throw it in the chat, everyone.
Yeah, it's definitely a chat.
Yeah, if you want to share what your discipline is, just throw that in the chat. First one was MEP, so that's
nice.
That's good.
There we go.
Yeah.
So yeah, here's Sparrow. So I'll just kind of run through an overview of it. So we kind of talk about ourselves a little bit more. It's always fun. Got some stuff just with data, rounding, generating lists. So we'll actually use this one later. Right, we have some Dynamo stuff to get graphics, info about your version, some template stuff, some time, some UI stuff. But the real heart of it is geometry. So I won't go through all these. There's a whole bunch of fun stuff. We try not to we haven't really tried to duplicate. Maybe we did on accident. Any nodes that are in the you know, default library. And then some math stuff. So a lot more to add to here. I'm actually wanting to add engineering functions in here. So like, right, I'd like to have like the fan curve function so I could solve for whatever I need and all those engineering equations. And then a lot of stuff with Revit. And where we're going to get started is we have a section in here called selections. And this is kind of that idea of really being able to get information out really quick. So Mesh has done a really cool job of building some nodes that really streamline the issues that I've seen with trying to scale these things up. Mesh, do you want to talk about any of these?
We can talk about the link collection. So basically, us as MEP engineers, we always have to link architectural models to be able to start our job and work. So to automate our workflow, we need to collect many linked elements. So ceilings, walls, rooms, if you want to automate the creation of the spaces. So that's kind of a little bit a missing feature in the built-in nodes in Dynamo. So one of the many collectors we've added through Sparrow are linked element collectors that can collect these elements. So and that's tricky because I'm going to take an example of linked elements that are visible in view. So you need to find the elements that are visible in your current host model view, but the elements are in another model, so you can't use the default Revit API collector. So we had to go and find a trick for that. One of the tricks was to tag all elements and check which elements, which linked elements have the tags visible in the view, so that we can get those visible linked elements in the view. So that's one of the workarounds we used. So linked element collectors were a big addition for us as MEP engineers in that field.
Yeah, I always had a problem of phases, right? So are the phases matching? Is phase mapping done? Mesh really knocked it out of the park with just seeing if they're taggable in the view. So awesome work there. Another thing that I'm always tired of doing is, right, get my category, all elements of category, and extracting parameters. So we have some nodes in here that just get stuff really quick. Again, we're working on it, but the idea here is the dictionary is to actually pull out parameters in geometry as well. So rather than doing all that, we have some nodes in here just to get the stuff that you want really quick. So then kind of example of getting that stuff is, right, so out of all of our spaces, we have this one, which is space dictionary geometry. So this goes through, and not only does it clean up some of the geometry, so sometimes pulling geometry out of Revit, it's really stubborn. You have like self-intersecting walls that cause problems. And, it's just nice to have some attributes about the geometry. So here, we ran all of our spaces. We can get the hollow points. So this is a dictionary, right? So I can go. And then I can start pulling this stuff up. Another thing I really like about a dictionary is we can carry this whole dictionary as one list. So I can filter it as one list. And then also I can retrieve stuff out of that list just by using, a regular string rather than having to get the item from an index and having to keep track of those indexes throughout a large workflow. Lowercase. What did I do? No space. Right, so you can start to see if you. So why is it important to have all these characteristics of stuff? So there's our hull points. We have this rectangle, which is actually like the minimum rectangle. And then here's a nice data shapes one for you. Right, so now that looks crazy, right? We got all these rectangles, but what these are the minimum bounding rectangles around that space. So now why is all this important? So it's really one of the interesting problems that comes with computational problems is like, right, the human's really good at seeing, let's go into Revit real quick, seeing a space like this one. I mean, like, oh, that's mostly a rectangle. or maybe we have, you know, like big L-shaped spaces. The computer actually has a really hard time understanding that, so you kind of have to get these characteristics about it to start to place stuff. But let's keep going forward with. So, right, so there's our surfaces. So we have this other node that really quickly gets you your surfaces, and you can do it at whatever elevation you want. So I've actually used this for getting the boundary curves at certain elevations for things like placing receptacles and stuff.
I think that answers one of the questions in the chat about getting 2D and 3D and 1D geometry from spaces,
Yeah.
which can
Yeah.
highlight space boundary node.
So we've explored this a lot because it's really hard to find that global solution. So here's one where we take spaces and we get the curves through the API. So option one, right? I think this one's pretty much the same. It's C#. So this one, right? C# will run quicker on if you're trying to do it across a whole project. This one's Python. This might actually be design script. I'll let you guys explore it. So that's actually using the API to do a solid intersection. Yeah, there's a whole bunch of methods. It's something that we've dealt with a lot. And I guess I will open this up for you guys to see how much is going on in it. So this is what we've done to try to clean up the geometry when you have self-intersecting stuff. So again, this is kind of the idea of just being able to get what you need to do the workflows and not running into pesky errors because of, you know, geometry that's coming in. So once we have our surface, we can do things. So let me go over here and go to surface. So if I close this one up and go to geometry, we got quite a few surface nodes with more to come. All right, so we can get the centroids. This is just the center point of the surface. I'm working on one that gets like the inner centroid, and then we have some packing algorithms for it. Getting the outer curves. Here's getting the inner centroid. This one actually came from Springs, maybe? But this one's pretty cool for like, so you can see on this L-shaped space, right? It kind of got it. Or here's a really good one, right? It's really actually hard to figure out where this point is if you have no idea what the polygon is, if that makes sense. Like if you know it's an L, it's not that hard. But if you don't know it's an L or it has a lot more little lines, of course, that come in with spaces, it's kind of a problem. So then we have these circle packing ones. If I unfreeze this, unpreview it, I mean.
Sean, there was a follow-up
Yeah.
on the 1 and 2D geometries. How do you know if your MEP families have embedded symbols apart from 3D solids, for example? More specific, same question.
I will throw that out actually to Clockwork has some nodes, I believe, to access that kind of information.
I can give him if the person that asks the question has a bit of knowledge in the API, I can give him a pointer about that he can achieve through IronPython nodes. So if you're collecting geometry, you can also, you have a certain class that is called it's a geometry collection option. So in that class, you can specify you can just keep the view parameter as null and keep it. So if you keep it as put the detail level to fine, you can get all geometry in that family, whether it's visible or not, whether it's a solid, it's a line. Then once you get the geometry object, you can check it and cast it as a line, as a solid, as all the classes, the geometry classes. And once you cast it, you can check whether it's still valid or not. If it's not valid, then it's not a solid, it's a line. So that's one way to achieve it through the Revit API. And if you know C#, you can do it as a C# node, or if you're more familiar with Python, you can do it through an IronPython script.
Yeah, I was actually going to show something. Where'd this door go? I have a door loaded in my family. And then, of course, I loaded in just the wall opening one. Yeah, there's a lot of nodes out there too. This one node that I'm about to show you is really cool because it can actually get like the swinging, the symbolic geometry from families that's in here, and that can be used to place like understand how your door opens, and then you could use that for even placing like light switches and stuff like that. So, do you know how they do that, Mej? If you want to talk about that while I get this silly door loaded in here.
To get the geometry of that door.
Do you know how they get the symbolic lines through the API?
Yeah. I just gave a detailed one. So it's the options class that needs you just need not to specify to keep the view property of that option null and to put the detail level at fine, and you get all the geometry, and you can just check its type through an if statement. And when you check its type through an if statement, you can know if it's a line or if it's a point or if it's a solid or if it's a mesh.
Nice. Oh, come on, Revit. I will leave that one at that for now. Yeah, so play around with this. Get in there, elements. So if you put a door in here, you'll get those curves. So hopefully that answers your question. So then we have the space packing, right? And so what's really interesting to me is like all the generative design. It's crazy to me how much generative design stuff really starts with some type of grid or some type of placing points in a circle packing pattern within a space, right? And then of course the whole idea, should I dare go into automatic? The whole idea is that we can scrub through these to start to get different layouts. So this might be lights, this might be diffusers, right? Fire sprinklers, whatever. So diffusers, you might have a little bit of an offset that you're willing to go out of the boundary. Maybe you want to come into the boundary a little bit. And then, right, you can just kind of scrub where the starting point is of the surface. So that's one. And then we can take all this and we can do different patterns.
So that's also applicable to architectural design. So especially now with COVID and all those generative design algorithms that try to optimize office distribution and office spacing, not to have crowded work spaces. So that's the same thing. Same as the way you would distribute diffusers or lighting, you would distribute your offices with a certain spacing.
Yeah. And you can start to get statistics out of here. So I put this in here just for fun, right? Coverage area. But this I guess, of course, again, you can take these out and just plug them directly with Refinery and try to maximize this through that. So that's kind of the idea of the generative design stuff. So I guess when my stuff gets too big, let me try to bring these back to like. Yeah, we'll do that one for now. So now let's take this stuff and, right, so we can get the center point of stuff like this. So now we have these circles out, and maybe we want to place stuff at this. So one of my favorite ones. Now we have the center points of the circle. Honestly, ray bounce is one of my favorite nodes of all time. I think it's really cool. You can do with it. It opens up a lot of potential to do stuff. And of course, it's not working. Live demo luck. I'm
gonna answer a question in the meantime.
Yeah, please help me.
So yes, so it's a follow-up to the previous question. So yes, definitely. So once you get the geometry and you've checked through an if statement or through a conditional statement what type it is, you can just take every in the same conditional statement. Once you get what the type is just added to a certain list of its own. So for example, if you have meshes, you add once you find a mesh, you add it to the mesh list, and the solids, once you find a solid, you add it to the solid list, and then you can have an output that gives you a list of lists, and each list of lists would give you the number and the IDs, not the IDs, but the instance that you're looking for. So yeah, that's the way to do it. You can also have multiple outputs. So yeah, just add each element to a separate list once you find what it is.
I figured out what I did, by the way. Those were the ones without ceilings, without any type of boundary thing. So yeah, so now that we have, right, so we did some type of layout to get some, let me go back to automatic. Right, so the ray bounce we can shoot up and we can get these ceilings by shooting an array. I always like to have a Dynamo view because I use ray bounce a lot inside my projects, and I can just call that view and I can manipulate that view for whatever needs I have without, you know, messing anything up, making my colleagues angry. But it's really nice about the ray bounce nodes. We have these points and then we have these elements. So I think our biggest crowning achievement so far is being able to get the ceiling grids into Dynamo. Oops. So this is just getting the boundary curves, not that big deal. That one's actually, I think, exposed, but then we can go up here. You can see we have our link instance there, and then giving a preview of that, and now we have our ceiling grids. And right, this has huge potential. So with a little bit of work, we could take these ceiling grids, figure out the center, and then actually place this stuff in the ceiling grid, and maybe even coordinate between lights. Do you want to talk about that, Mesh, how we did that?
Yeah, so about the ceiling grid extraction itself, so that's a little bit of a big thing because they're not easily accessible through the API because ceiling grids are actually a pattern. It's a model pattern, but it's still a pattern. So you have to go through a workaround, which has been circulating over the internet a lot for 4 or 5 years. But any public version you might find is always flawed or is not complete. So that's why it's a kind of a big thing. So basically, what is happening in the background is a conversion of references to a stable reference, which is something a little bit advanced through the API, and a bit of annotation to be able to really detect where the grids actually are. So that's kind of a big thing for us. So then once you want to align the stuff, you can always take the intersections of the grids, and each grid would be separated into its own rectangle. Once you get its own rectangle, you can find the center and check what elements lie inside the center. Once you check that, you can, if you have 2 elements of a different category or of a different kind, you can move one to the next grid. That way you can achieve multidiscipline coordination between ceiling hosted elements such as lighting, diffusers, sprinklers, and so on. So yeah.
Yeah, some more to come there. Right, and then of course, once we have these points, and so hosted points too, what I like about ray bounce is you can get the face then at that point, and then be able to do even hosting stuff. But of course, we can take these points and, you know, you can start to put stuff, populate your models. That's the really kind of exciting part is whether this is diffusers, obviously I just put VAV boxes, lights. It's really cool that you can just start populating stuff. And to me, it's not just about the putting it in the model. A little bit more work, you can start to fill out all the parameters that you need, and you can start to build relationships. So when I put this in here, I already in Dynamo, I have exposed what space it's in, so that I can put that space information in and start to build kind of a relational database to you know, build up even more complex things. I guess I wanted to show another cool idea with the ray bounce. I need to get, so the idea is that you take, let's say you have your couch, right? You could select that. All right, let's just say you have this desk right here. You could select that and then use the ray bounce to shoot a ray up to the ceiling there, and then like place a light directly over that desk. And the idea with the couch is, or this coffee table, for example, you could select this coffee table and shoot a ray bounce to this wall, and then shoot a ray bounce to this wall, and now we have a line. So now we can like maybe find the center point of the line and then build a grid around that. And why you'd want to do this, because architects a lot of times make really big rooms that, right? So if you're to collect the surface of a really big room, it's hard. You couldn't place like a simple rule for placing a grid of lights in this living room if this whole space is one space. That makes sense.
Does the insertion point of the family matter at all for this ray bounce?
Yes.
Or yeah. So
not for the family. I guess not for the ray bounce, but right. Yeah, that's a really good point.
Because that desk is at the corner, which is a really crappy insertion point.
Yeah, it was supposed to be a table.
Oh, okay.
Yeah, the families. It was supposed to be like a dining room table, but
yeah, that's the classic desk that comes with the out of the box template. It's a piece of crap. Yeah.
Yeah. Yes.
Right.
Don't deny that.
Yeah.
Yeah, and I think that's part of all this automation, computational design is, right, establishing this Revit family. And I would say more, if you're placing stuff with Dynamo, you really need to know about where your insertion point is for that family. You know what I mean? So if something is, sits on the ceiling and it's not hosted, well, you need to know exactly. So there's I don't know about an art, but yeah. So when you build your families and you're trying to do automation with Dynamo, just pay attention to that. Really anything, right? And that's kind of one of the struggles with trying to make software that works for everybody is everyone's using, families that are built differently. So that's why this is a good point too on why I think computation, the skill set's so important moving forward. I personally think it's going to be really hard for.
Yeah, so one of the universal solutions to that, because you might have a custom insertion family, it might be on the corner or anything, and you want your own ray bounce to go from the center. So it's easier to get the centroid of the solid or to get the center of the bounding box of the element. So that way you can make sure that the insertion point doesn't really affect your workflow, but there's still always checks to be made and edge cases. So we're hoping through Sparrow to try and get feedback about any edge cases that might occur.
And that getting the center of the bounding box or the solid would work well for things like furniture where it's relatively boxy. But again, when you're L-shaped example of the room over there, then you suddenly have a problem because the center might be off, outside the solid now, right?
Exactly, so, right. And that's where like that inner center, like maybe you could kind of get the center. So it's not really a cut solution. And that's why there's so many different methods in here for trying to get this stuff. So
yeah, interesting.
Yeah, it's an interesting road we've been down trying to figure it out.
Yeah, I'll bet. Okay.
So so then the solution is to take all of this and then maybe have multiple ones and then run those through something that's going to score it, rank it, and tell you which one is the best method for that. And then, of course, you run into issues with computational speed and everything. So it's fun problems. That's why I like doing this stuff. It's always new problems. It's always interesting problems. Me and Mej were actually talking last night about it and like what got us into it. And it's funny because we were talking about like you go through college and all this and you learn being an engineer, right? You have to take like Calc 3. So you learn about vectors, surfaces, normals, all the stuff that you find in here. But then you forget about it and you start just doing stuff in Excel. And then you just use your eyes and you click your way through doing all this stuff. We both enjoy thinking about the calculus that we learned, yet we don't have to do the calculus, right? Because in here, right, curve, give me the normal, surface, give me the normal. These nodes do that stuff for you, but just thinking through those geometry problems is a fun challenge for both of us. So, yeah. So then I guess the other thing that we really worked on was the new systems analysis. I don't know how many people are familiar with this Revit systems analysis. Maybe I should show that real quick. So Revit, they've been working hard. That's like the third time I think they've scrapped and started over with how they're doing loads. But 2019 is when it started. So you have this analytical systems tab here, right? And the workflow right now is still really silly, in my opinion, because it's still very manually driven. So I have to make a water loop, and I just make these air loops. And then I have to go set a whole bunch of parameters for these things. So I have to name it, right? Maybe air handling 1, right? I don't know. Then I have to like assign it to things. And it's just very, oh, so this is the sketching. So then I have to draw these sketch lines like inside Revit. So maybe I want one piece of equipment. It's not very good zoning on my end to serve, these 3 spaces. I have to do that. And then I have to do this process over and over and over. Well, we didn't like that much. So we thought, hey, could we take some of the stuff we've done in Dynamo and hack this? So Mej went ahead and made it to where we can make water loops. Right, so if I want to make a water loop, let's say I have a whole bunch of them, right? So I'll do a little A dot dot D. Right, so there's my 4 water loops. And then I can get the parameters, and I can set those same parameters that I had to manually set in there. And then there's more of them. Let me go down here. So Revit, Sparrow, Revit analytical systems. So we can actually make, so then you have these, so that's the zone system, and then you have the air handling unit. So you can make zone systems automatically from spaces, or you can actually, so there's the water loops that you'd want to make. Then a zone equipment by lines is really interesting. So Mej, you want to talk about this one and your journey and our journey through figuring this out and having to hack the API to do it?
So when we did that back in 2019, it was the release of Revit 2020.1. So the SDK was still not documented for all that. So we had to go and figure that out through some debugging to know each class and which classes have been added and where they belong and what are their namespaces and their properties and constructors. So what we basically done is basically all Dynamo nodes are, especially zero touch and built-in ones, are they're basically a translation of the construction of the Revit API constructors into the nodes you see in front of you. So basically what a node is a C# function that reflects Revit API functionality. What we've done is take all those constructors and turn them into nodes that can be used to automate all that usually boring and manual workflow. So we had the constructor of the system zones converted into a node, the constructor of the 4-pipe system converted, the constructor of the air loop systems, and so on. So yeah, that's basically what has been done to be able to automate all that through Dynamo.
I guess too, I don't know if I have it since my computer crashed last time, but what was that add-in that you showed me? That was really useful.
Revit lookup.
Sorry, I'm trying to drive Revit while you're talking. Yeah, so then the idea here, and so what another node that we have in here is just random points. So I use this a lot for testing. Also in here, another little fun testing thing is you have these polygons, and they're pretty much all the Tetris blocks. That's what inspired me to do it. But so you can make random, you can just generate surfaces fairly quickly to do tests on and stuff. So I don't know how many times I wrote something to make like random points just for testing, or as in here in Revit drawing surfaces or making spaces with walls just so I could get, you know, a random polygon and stuff. But if we have all these points, so let's pretend that all these points out here are some type of mechanical equipment. Maybe it's some type of plumbing fixture. Maybe it's electrical receptacles, right? So then what we want to do is we want to group that stuff to make systems. So if we go to points, we have a whole bunch of nodes for grouping stuff. So you can get the centroids. Let's say, right, maybe all these, you already know that all these are on one air handling unit. And so I want to get the center point of that cluster of spaces. There it is. And then maybe I want to project this point up to the roof level. And then I could place my air handling unit. Another fun one is, so this one Mesh actually wrote me that just pairs stuff by groups. So this just pairs the closest points together. So if we were to make a line, and so you can start to kind of make graph theory stuff with this. And there's quite a few nodes and more coming that we want to do on graph theory and starting to build these networks from, which is really the next step, but that's why I bring it in here. Actually, I think this one came up from, we were importing, I was tasked with importing stuff from an AutoCAD file, and the names and room numbers were on different layers, and there's no way to pair them up. So this was the solution. They're always close to each other, but this was how we're able to pair up the annotations and then pick them together. I think that's where this originated, but I've used it for a couple other things. No, we want Sparrow. So the group by parameters one. So this one's interesting. So I'd put my points in here, right? And then I have some sliders. Let me grab these. I'm going to put true. It's kind of cool to see what's going on. Of course. Let's see, what did I do? So we just pull this out. So yeah, I guess this is a good point. If you come in here, right, most of these are open source, so you can come in here and open it up, see how we did it. I'm obsessed with design script. I hate spaghetti. So I try and use a nice design script. And I can tell a story right here about the stupidest thing I've ever done in my career so far. When I was trying to get into Dynamo, I was doing a pitch at my company, and I wanted my BIM manager was suggesting that I clean up the code, and I said, no, I want them to know how much work I've done. Now I know that's idiotic, and the cleaner the code, if it did what it said it does, and it was clean code, they would have been way more impressed rather than seeing, the mess of spaghetti. Plus, I think this stuff's just easier to edit and see what's wrong. But you could just pull this back out to maybe diagnose it, because obviously something's going on. And this is a definition, by the way. I do that. Definitions are good because they just run faster, especially in this environment. I don't know if it makes a big difference if they're in a custom node, but all the geometry doesn't have to be produced in the background. Oh, I think I know
someone says here they think the parameter input is wrong.
Yep, I think so too.
Okay.
Thank you, whoever that was, though.
Yeah, that's Thomas there helping you out.
Yes, geometry goes here, and parameters is like a list 0, 5, let's just do 0.5 for now. Thank you. I don't even know how to operate my own nodes. Oh, come on. Is that gonna work now? I need to brush up on how Sparrow works. Let me go. Let me see what else we got. So group by distance. This is a cool one because you can start to group stuff by margin. So with no margin, default of 1. Maybe we put in a 10. Right, and we start to get these. And k-means I was having trouble with either also. So obviously something's going on. Here's the minimum rectangle around points, which is really useful. And another way that you could use this one to group stuff is now maybe you could divide the space up just using the edge parameters. There's random points. Alpha is cool. I'll let you guys explore that one. Let's see if k-means on points will work. Beautiful. All right, this will get me going where I wanted to head. So one of the coolest things that I discovered, and talking about built again, so I submitted a class about built, and I didn't really know how I was going to do it. And same bit manager, actually, I was talking to him, and it was like a little bit before our paper was due. I was like, I have no idea how I'm going to figure out how to find the clusters of spaces that like zones need to be on. And so k-means ended up being the solution. And it's a machine learning clustering algorithm. And so there's a whole bunch of them out there. This is honestly the simplest one and the most intuitive to understand. But what this is doing, so if I go to Dynamo and go to graphics and go to rainbow, oh, why is stuff just not doing what I want it to do? Do it this way. All right, so if we look at our clusters, and I look at the first one, oops. Oops. Because it's a dictionary. That. Right, so what this thing is doing is it's grouping points into like the most common clusters. So now we can see that these points are in these individual clusters. And if I were to change this value to maybe 4, then we can see it generates different clusters. They're all clustered together. Oops. So where this is going now, so now I could like find the average point of these, which is my centroid, and I could start to build out. So let's say I had a floor plan where I wanted 4 air handling units. I could put in my 4 to figure out which spaces should be grouped together, get the clusters of spaces, find the average point, put my 3D element maybe on the roof, and then also build my analytical systems really quickly. And then you can even run analysis and do a whole bunch of stuff. So I guess we're low on time. I hope that makes sense on kind of just the way and thinking of going through this. So again, the idea was right? We have some spaces probably coming from the architect rooms. We can extract their geometry really easily to get their surfaces, right? Then we can then use some type of packing surface grid algorithm to get spaces in that point, and then maybe place diffusers, lights, whatever on that. Even get the ceiling geometry to coordinate those ceilings, right? Then we can go in here and start to use k-means, the grouping by circle, to group those system elements together, and then start to build and place our 3D system elements for MEP and our analytical system elements.
There's a question there. He says, I don't understand what K count is. Can you elaborate on that a little more?
Yeah, so the K count is the number of centroids. So if I were to do 5, right, it's going to say, so it's the starting number of centroids. So it's how many clusters you're going to have as the output is what the K is. Right, so at 5, I have the 0, 1, 2, 3, 4. Right, so there's my 5. If I were to go back to 3, then right, cluster 1, cluster 2, cluster 3.
So it's the same collection of points, you're just grouping them differently.
Yeah, exactly. Right, and the cool thing about this is, actually, if you dig into more about k-means, this kind of does it for you, but even like starting where your clusters start actually could create different options. You know, it's good, right? It's an iterative process. So again, all the buzz, generative design, this could feed a generative design algorithm to produce a whole bunch of different scenarios. And then if this was air handling units or it was receptacles, you know, and we're trying to find the amount of panels that we need and kind of where they should go, and if we can measure that stuff in the back end,
so
we can identify, you know, the best scenario, and then do all the Revit integration stuff at the end.
All right. From the rest of the group here, are there any other questions that you'd like? We can maybe just do some free-form Q&A at this point. What do you think, Sean?
Yeah, I think so. 3 for communities, guys. Like I said, we got Mej, who's an API expert. I'm usually a Dynamo expert, so yeah, by all means.
Don't be shy, anyone. I'm not a MEP guy, so I don't have any direct questions. Oh, here we go. Let's see. Is there do you have no documentation anywhere? That's the classic, right? You build all this stuff and then you realize, oh, I got to teach people how to use it. So
yeah, we are in the process of that. If I actually go back to the PowerPoint, yeah, we want to do that. That was one of our goals. So yeah, if you go through here, so these, you know, a lot of these, so this is actually, here's a good point. This is a diffuser one. So this uses some of that stuff and actually goes into refinery. Then here's the ceiling grid one where it actually works and runs and aligns them up to the ceiling grid, straight out Dynamo player. But yeah, I guess the answer is we're in the process of it. And part of that is here with doing this. So at some point when we're done with this, we're planning on sharing this slide deck somehow with kind of how to use it, and then maybe even add some brief you know, a little bit more explanation. And also the idea is to do the YouTube channel. We actually already have it kind of broke down in sections, but we're just going to talk through and go through the nodes on the YouTube channel. But yeah, time is our problem. So
yeah, but in the meantime, if anyone has any question, we're easily reachable on our social media, whether on LinkedIn or Twitter or even through emails. So and any emails or messages are always immediately answered. So
yeah.
All right, there is another question that came through the chat. Did you try to play with the splitting of piped duct and inserting some equipment between the split?
I have done that. Yeah, I don't know. I can't answer your question. That actually, If I'm really honest, I'm gonna be 100% honest here. I was doing that for a client, and I got so angry that I smashed a mouse. True story, 100%. You ask my wife; she's like, "What is going on?" Yeah, it's possible. We were actually switching out VAV box sizes, so you had to like disconnect it. And another funny story in that process is because we were testing it vigorously, and we actually found an error inside our Revit, and we sent it over to them. I forgot what it was. It was like when a connector comes together. Yes, it is possible. I guess that's a straight
Yeah,
question. It's definitely possible.
And there's
not
also definitely not easy, but it's also achievable in way more automated ways than having it through Dynamo. So if you go through the Revit API, you can have it happen automatically as soon as you draw the duct. So you can draw your duct and set a splitting distance to your segments, and draw your ducts and have the ducts automatically split and have it segmented. That's something also that I've personally done for also as a custom job. So yeah, definitely feasible.
There's also the MEP Pover package that's actually the package that I used for that thing. I was and this actually how you can make your systems as well. So we did the analytical systems, and MEP Pover package. It's another funny story. MEP over. It's not MEP over. It's ME Pover. I forever thought it was MEP over. And I was like, oh, that makes sense. The guy that built his last name is Pover, so. But yeah, there's stuff in here somewhere. Connectors. The easiest way that I've found to do connectors and stuff is lay down pipes first, and then there's somewhere in here there's a node that's like you take a list of those pipes, and if you put 3, it's going to make a T. If you put 2, it's going to make an elbow. So here's connect 2. That would take 2 connectors and connect them. So this is where you want to start looking for that stuff.
All right.
I think this package is really nice. Thanks, guys.
Yeah, thanks. Obviously, it has some errors. It's definitely a work in progress, but we're excited. I'm really excited for with the new Python libraries are going to be accessible. And something I really want to, I guess, push. Let people know, like, you don't really have to, again, like, I didn't write a lot of these geometry codes, the community did, and I'm just bundling them up mostly for myself. You don't have to be a coder, like a really good coder, especially with the new Python being able to do, like, there's tons of libraries out there that are going to let you do a whole bunch of cool stuff. So for me, I think it's really just good to try to start understanding the concepts of how to deal with polygons, and rather than having to know the code line by line, because the community everywhere, just in coding in general, is so giving, I guess. So
yeah, so basically the first rule of any machine learning development is so you're gonna use an open source library at some point. So yeah.
Well, awesome.
Yeah, so hack it. Let us know when it breaks on you. We'd love to hear from you. Let us know any ideas and stuff that you build with it. Like anything, right? Just kind of explore, play with it, and that's how you'll get better and understand what's really in there. So.
Well, fantastic. Well, thanks, Sean. You guys are our first official MEP presentation here in the group. So I was trying to mix it up a little bit. We're a little heavily architectural focused, so I'm hoping that the folks that were asking questions especially appreciated it. And it seems like we definitely have some MEP folks that joined in. So I'm glad that we were able to provide something for them. So yeah, and everybody knows how to get a hold of you. So we'll let you know if there's any feedback from the group.
Cool. Hopefully start seeing each other in person soon and everything. So
I know, right? We're going to get those in-person conferences back online soon.
Mej's going to have to come to the States.
Yeah, Mej, you're going to come?
Yeah,
Good to hear.
definitely.
Built is around the it's around the globe, so maybe maybe one of the international ones too.
Yeah.
All right, gentlemen. Well, thank you very much.
Thank you, guys.
All right.
It's been a pleasure. Thanks.